In this lesson we do some work on curve sketching. Examples. We're asked to consider the curve y equals x times x minus 3 squared. We need to find where the curve cuts the x-axis, then find the coordinates of any stationary points and determine their nature, and then sketch the curve for the domain -1 less than or equal to x, which is less than or equal to 4. Let's take a look at the solution now. Okay, firstly, find where the curve cuts the x-axis. So the equation of the curve, let's start by writing that down. Now it cuts the x-axis for what value of y? Well, when y equals 0. So we set that equal to 0, the equation there for y, set it equal to 0. We come up with this. And that is well, it's a bit more than a quadratic, isn't it? It's x times x minus 3 squared equals 0. We can look at it, break it up a little bit. We get that x equals 0 there. Or this part here, x will equal 3. That'll be the solution there. So x equals 0 and y equals 0. So therefore the curve cuts the x-axis at 0, 0. Okay, that's the origin. And the other point, when x is 3, and again y is 0, so the other point is 3, 0. Now, as we're going to be doing these questions, we'll just write down the information, the important information. Let's put it over here. Now, part B, find the coordinates of any stationary points, determine their nature. So again, let's just write down the equation, and we can expand that somewhat. Where at this stage, we've expanded the perfect square. And still now, we'll expand the brackets. So everything's being multiplied by x outside the brackets there. We eventually get that y equals x cubed minus 6x squared plus 9x. Now, dy dx. Well, the derivative of x cubed is equal to 3x squared. The derivative of minus 6x squared will be minus 12x. And the derivative of plus 9x, simply plus 9. We'll also find the second derivative. So we need to derive once more. So derivative of 3x squared is 6x. Derivative of minus 12x is minus 12. And the derivative, of course, of plus 9, a constant, is 0. So nothing more to do there. Now, for stationary points, we know that the derivative is equal to 0. In other words, the gradient of the curve is 0 for the stationary points. So let's set our dy dx equal to 0 there. Now it's a quadratic, but look, I can see 3 is common to everything there. So let's take the 3 out. So 3 outside of x squared minus 4x plus 3, all equal to 0. So let's put the 3 down, forget about it. Now we have a quadratic there, so two brackets, x, and we're after factors of positive 3, which add to be minus 4. And those factors will be minus 3 and minus 1. So solving that, we therefore get that x equals 3 for that part, or x is equal to 1. Now we're going to check the sign of the derivative, okay, to help us determine whether they are maximums or minimum turning points. So a little diagram here. We're checking it around the points at 1 and 3, okay, the x values there. Now we pick a number on this side of 1, okay, a value of x. Let's say x equals 0 would be the easiest number to work with. And we substitute into there, we end up getting a positive result. A number between 1 and 3, let's say 2. Again, we substitute into the gradient formula, we get a negative result this time. Okay, in other words, the gradient is negative for that part of the graph. And picking a number on this side of 3, often choose a bigger number, say 10, and we substitute it in, we get a positive result. So what does that mean? Well, let's consider 1, what's happening around about 1. On the left side of 1, the gradient is positive, so the curve will be going up. Then the gradient becomes negative, so the curve goes down. So what we've got there is a maximum turning point. What about around x equals 3? Well, on the left of x equals 3, okay, we have a negative gradient, in other words, the curve's going down, then the gradient becomes positive, so the curve goes up. So in this case, we have a minimum turning point. Now, to find the actual turning points, we're going to substitute into the original equation these values of x. So when x equals 1, we substitute in the very original equation there, and we get that y is 4. So we have the point 1, 4. When x equals 3, again substitute into the original equation, we get that y is 0. So the point is 3, 0. So we can therefore say that 1, 4 is a maximum turning point and 3, 0 is a minimum turning point. Again, let's just transfer that important information across there. Terrific. Now we need to sketch the curve. So we are going to consider what's known as the endpoints of the domain, because we are interested in the x values between -1 and 4, okay, inclusive. So we're actually including the -1 and the 4. So let's start with when x equals -1. We substitute that into the original equation. We end up getting that y equals -16. Okay, so that means we've got the point -1, -16. Now, what happens when x equals 4? Okay, I'm glad you asked. We substitute that into the equation. We end up getting that y is also equal to 4. So that gives us the point 4, 4. Right, let's draw our sketch now. So there's our axes. Okay, let's just mark a few things. Now, the x-intercepts are at the origin and at also 3 zeros. So there's the origin there, and then at 3, 0. What else we got? We've got a maximum turning point. Okay, let's just mark that in. Okay, that's our little maximum there at 1, 4. I'll draw a little bit of the curve there, not a great deal yet. And at 3, 0, which we've already marked, is a minimum turning point there. What else? We've got the end point there is -1, -16. Okay, I've already known how long the graph was going to go down. You might need to adjust this, okay? All right, so there's our end point, one of our end points. And the other end point is 4, 4. Right, now a matter of joining up the dots if you like. So let's just complete the curve there and label it with its equation. Fantastic. A great looking curve. Okay, the next one. The curve of the function f of x equals x times x minus 3 squared for that domain there, -1 less than or equal to x less than or equal to 4, is drawn below. Well, there it is. It's drawn now. Okay, and if you recognize that, yes, it is the graph that we just drew. I'm just going to ask some questions about that. We're asked, for what values of x is f of x decreasing? And what is the minimum value of x times x minus 3 squared in the particular domain we're working with? Well, the solution, firstly, part A. For what values of x is f of x decreasing? Well, when it's decreasing, that means the curve is going down. Okay, the values are when the curve is going down. So looking at our graph, we can see that area I've highlighted there from left to right. When we talk about the curve going down, it's always from left to right. The curve is going down, so we can say, and that happens between 1 and 3, the x values, 1 and 3. So f of x is decreasing when x is between 1 and 3. And notice we didn't include, okay, it's strictly less than. We didn't include the 1 or the 3 because they're actually stationary points at those points. Okay, neither increasing nor decreasing. Part B, what's the minimum value? Well, the minimum value is simply the lowest y value we've got. So looking at our point there, we can see that's certainly the lowest point on the graph, corresponding to a y value of -16. So therefore we say the minimum value equals -16. Excellent. Well, that concludes the lesson. Good luck with your questions.